peak inverse voltage. From the name itself it should be clear. So this is indicating some voltage when it is having maximum value in inverse direction. So this concept we are interested in case of the rectifier, and that's why let us see what is actually the definition of the PIV in case of the rectifier. So here you can see, for rectifier applications, the peak inverse voltage is the maximum value of reverse voltage which occurs at the peak of the input cycle when the diode is reverse bias. Of course, as we are talking of the inverse voltage, so it is the case in case of the reverse bias. Ultimately, its meaning is that PIV is actually indicating what will be the maximum value of voltage which will be applied across the diode when it is reverse bias. Remember, it is not considering the forward bias condition, it is only in case of the reverse bias. That's why it is called the inverse voltage, that is the reverse voltage. So let us go directly for the PIV in case of the half wave rectifier first. So here I have the diagram of the half wave rectifier, and we know in case of half wave rectifier the working you should be knowing. This is the input we are applying, and when this input is applied, we know that the voltage which we have here is Vm, right? So during positive half cycle the upper end will become positive and lower end become negative. During negative half cycle lower end will become positive and upper end become negative. This is the theory we already discussed. This is the diode D and load resistor RL. So as far as the waveforms are concerned, let me draw the waveforms. So okay, these are the waveforms now we have. So in this case we know this is the input voltage if we are applying, and let us consider the during positive half cycle. Let me just draw the waveforms once again, because here we are interested in the voltage drop across the diode, not across the resistor. So first of all, the voltage or the waveform across the load, you all should remember, is like this. During positive half cycle the current flows, and that's why we get waveform. During negative half cycle diode is reverse bias, we don't get any output. During forward bias again we get this waveform. So this is the waveform across the load resistor, or it is also called the V out. Okay, but here we are interested in this waveform, which is the voltage across the diode, right? So now if you remember the Kirchhoff's voltage law, we know that the total voltage is divided amongst the circuit. So whatever the voltage we are applying here, it will get divided into diode and resistor. So I will explain this term in two ways, first with the waveform and then we'll go with the actual KVL. So in the first case, as we know, if this is the input voltage we are applying, right? So this voltage has to get divided amongst diode and resistor. So during positive half cycle, here you can see all the voltage which is available in the input is available as it is across the load resistor, right? So what will remain? Nothing will remain. So that's why what will be voltage across diode? It will be 0, right? Ultimately what you have to see is, you have to draw these two waveforms such a way that if you sum up these two waveforms, it will give this, right? So if I add this portion with this, 0 plus this portion will give this, right? Again, during this portion, when the diode is reverse bias, what will happen? No current will flow through the diode. As a result, here is also 0 current, so no voltage will drop across the resistor. So what will happen? Whatever the voltage we are applying at the input will be available as it is across the diode. What I mean to say is, during reverse bias, as this voltage is 0, so that's why the all voltage will be applied across the diode, right? So if this voltage is having value Vm, as we said, we consider this previously also, this is the Vm na. So during positive half cycle it acts like this, Vm. During negative half cycle, so this is Vm and this is also Vm, right? So it means that during negative half cycle the voltage which is getting applied across the diode is Vm, but in the reverse direction. So that's why it can be called like this. Though its amplitude is Vm, but the polarity will be minus Vm like this here. And here it is positive Vm. Means if we are considering the polarity, so it's a positive Vm. Here it is minus Vm. Now again, as we were discussing, if we combine those two waveforms, we should get same input. So here you can see, if you combine the positive with 0, we'll get this positive waveform. If we combine this 0 voltage with this minus, we'll get this portion, and once again this. And in this way, we can say that the whatever the input we have, it is getting divided into the diode and this resistor. This is the waveform across the diode. That's why it can be called as VD. And this is nothing but the PIV, that is the peak inverse voltage which we are getting across the diode. Let us understand the same concept using the KVL. Now, as I said, here while calculating the PIV, we are not interested in the forward bias, because during the forward bias voltage across diode is 0, and again we know the peak inverse voltage we are considering when the diode is reverse bias. So we should be considering only the reverse bias condition. So during reverse bias condition, we know the polarity of Vm is like this, because it is negative half cycle we are considering, means we are considering from pi to 2 pi only. During this, again, as we did in case of the KVL, what we have to do is we have to consider the voltages across the different devices. So here the voltage drop will occur across this resistor. So let us say it is as a VO, no problem. And let's consider its polarity. So polarity, we have flexibility, we can consider as per our requirement. But let us consider, if this is the polarity, the current should flow like this. So if this is the case, what will happen? The polarity will become like this. This is positive, this is negative. Again, I am saying we have the flexibility to consider the polarity. Further, let us consider the polarity of the voltage drop across the diode is like this. And this voltage is nothing but, let us consider the PIV, because we are interested in the maximum voltage when the diode is reverse bias. So this is the polarity we have considered. So applying the KVL, now we can write, now let us move through the loop in this direction. And this is the, let us say the value of current is IL. Why IL? Because during the reverse bias, the very small current, that is leakage current, flows. And that's why we can write, now we are moving like this. So we are moving from minus to plus. That's why it's a Vm. Then further it is voltage of V0. That's why we are moving from positive to negative end. So that's why minus V0. And then here we are moving from positive to negative. That's why again minus PIV is equal to 0. Now once again, as we are considering this case in the duration only pi to 2 pi. So here you can see, during from pi to 2 pi, the value of output voltage is 0. Why it is 0, that I can again explain. Because during this period, the value of current which is flowing is IL, and IL is nothing but a reverse leakage current of the diode, which is very small. So we can say, here I will write, for time duration, that is omega t, between I should write like this, for omega t equal to pi to 2 pi. Let us consider, we are considering between pi to 2 pi. Okay, value of leakage current is very small. We studied in case of the diode also, the value of leakage current is very small, and that's why we have V0 is equal to, nearly it is 0, and that we have shown here also. So that's why if I put this value to be 0, what I am getting, Vm minus PIV is equal to 0. So ultimately PIV, that is peak inverse voltage of the diode, is nothing but equal to Vm. It means that in case of half wave rectifier, when the diode is reverse bias, the maximum voltage which can get applied across it is equal to Vm. Now once again, let us remember why here I am not writing minus sign, because I am calling it as a peak inverse voltage, means the peak value of the voltage in the reverse direction. That's why here we are writing PIV is equal to Vm.